Assalamu alaikum wa rahmatullah. I welcome all of you to our second class. In this class, we will solve problem 3 according to the material. This one has to do with resolution of vectors. We say that if a vector is inclined, it has components along the x-axis and also along the y-axis. Uh, we have a problem here that says find the x and y component, which is the effective value of the vector that they are going to mention, of a 25.0 meters displacement. You have a displacement vector. The magnitude of the vector is 25.0 meters, and the angle it makes with respect to the x-axis is 210.0 degrees. So the question is, what is the effective value of this vector along the x-axis and its effective value along the y-axis? Okay, before we proceed, I would like to remind us of a concept in mathematics. In mathematics, you have uh, 4 quadrants. This is the first quadrant. A quadrant is 1/4 of a circle or 1/4 of a circle. If I made a complete circle here, you can see that when I divide it into 4 equal parts, this is a quadrant, this is a quadrant, this is a quadrant, this is a quadrant. This is the first, this is the second, this is the third, and this is the fourth. Now, angles usually are measured from here. You have 0 degrees here, then we measure the angles in anti-clockwise direction. So from here to here is 90 degrees. Every quadrant is 90 degrees. If you move from this first quadrant to the second quadrant this way completely, you have 90 plus 90, this will be 180 degrees. Then this is another 90 degrees, so if I bring this down to here, I have 270 degrees. Then this is another 90 degrees that I have here, so 270 plus 90 will be 360 degrees. So we are going to measure our angles like this. Look at the angle. From the value of the angle, you can understand whether it is in this first, second, or third quadrant. The angle we are given is 210.0 degrees. 210.0 degrees. 210 is more than 180. You see, it's more than 180, so it cannot be on the second quadrant. First of all, let's start from the first quadrant. It's only 90, so we can't have 210 here. If we go to the second quadrant, you see completely we have 180, so we cannot have it here. The third quadrant is 270. If we add 90, 90, 90, 270. And what we have is just 210. So this means our angle is somewhere here. We can draw the angle somewhere here. Can you see that? Okay, so let's say from here to here is what? 210 degrees. I just want to give you the basic knowledge you need to solve the problem. Now, to solve the problem properly, we need to draw the XY plane. We need to draw the XY plane. Let's see. I am going to use this one to draw the XY plane, and class I'm going to use my dash line for the planes. Okay, this is my Y plane. Then I will now use here, see, okay, this is my X plane. So I measure from here to here is 90. Let me use this one. From here to here is 90, then down to here 180. Then I have to enter here so that I can get 210, the 210. But I cannot get to here because this completely is 270, and my angle is now 270. So I will draw a line, my vector from here, from the origin here. This is my vector. See, this is my vector here. Now this is my 25.0 meter displacement vector. Now we can see that it is inclined. Remember, in the class we said it has component along here, and it also has a component along here. The component along here, we can bring it here. So I'm going to use a different marker for the component. So its vertical component can be drawn like this. This is its vertical component. See, this is its vertical component, and its horizontal component is here. From here all the way to here, you have the horizontal component. Okay, now how do I get the value for my horizontal component and for my vertical component? I need the small angle here, because what I have here is a right angle triangle. So I need to know this small angle. I know that from what I am given, from here all the way to here is 210.0 degrees, but I also know that from here to here is 180. So I will say 210 minus 180 degrees. So you bring your calculator, and say 210 minus 180, and this will give you 30 degrees. So the angle you have here inside is 30 degrees. The magnitude of this and then multiply it by the cosine of this angle. That will give us the x component. And since this is directed along here, opposite this is minus x here, so what we will have here will be negative. So we have negative, then we take our 25 and say cos this angle 30 degrees. Then if we want, this is our x component. If we want to get the y component, you see it is pointing downward. Upward is plus y, but downward, remember, is minus y. So it means this one should also be negative. So we have negative, we take our 25 here and say sine of the angle that we have here, 30 degrees. So this is our x component, this is our y component. From the side here, we can simply say, okay, x component is equal to, then we take here minus 25 cos 30 degrees. So we bring our calculator again and say, okay, we have a negative 25 cos 30 degrees, and this will give us minus 21.65. Since it is a displacement here, the unit is given in meters, so we write the meter here. To get the y component, we say y component equals, then we take this one, this is our negative 25 sine 30 degrees, and this will be, okay, sine 30 degrees, we say negative 25 sine 30 degrees. This will give us negative 12.5. So we have negative 12.5 in meters. So this is our y component, this is our x component. I hope this problem is clearly solved and you understand it. In case you have any question, I can see that on the comment section. Assalamu alaikum wa rahmatullah.